Welcome to lesson 5.1 and 5.2, where we will be discussing direct and partial variations. So direct variation is defined as a relationship between two variables in which one variable is a constant multiple of the other variable. A constant of variation is the multiple, it's the constant multiple, and it is often represented by m, or the slope. If y varies directly with x, then the constant of variation can be defined by the following equation. M equals y over x. And then this is where we get our equation of y equals mx. And the graph of a direct variation is a straight line that passes through the origin. And keep in mind that the origin is the point 0, 0. So where do we get this equation for y over x? Well, we start with the difference in y over the difference in x, which is also the rise over run. And since it goes through 0, we can just state that x1 and y1 are both 0, right? Because that's the origin point. And so we have y2 minus 0, which is just y2, divided by x2 minus 0, which is just x2. So we're left with y2 over x2 and m equals y over x. And so from there, we can get the equation of y equals mx. Now, it goes through the origin, and this is very important because if it doesn't go through the origin, then y won't be a constant multiple of x. Okay, so constant multiple means that, 2, 4, 6, 8, those are all multiples because they're separated by 2. 3, 6, 9, 12, those are all multiples of 3 because they're all separated by 3, so on and so forth. So in example 1, we're going to be given two tables and we want to show whether or not it has a direct variation. And so we see that if it goes through the origin, then it needs to go through the point 0, 0, which in this case it doesn't. When x equals 0, y equals 7 in this case, not 0. So this does not pass through the origin, therefore this is not a direct variation. Now we have our second table, and I copied it twice, so these are the same table. Now notice that it does go through the origin, so right away that satisfies our first condition. But our second condition is that it still needs to be a straight line, so we need to check the first differences. Now we need to see, is x evenly spaced? In this case, yes it is. And is the change in y constant? In this case, yes it is. It always goes from the bottom up, minus 3, minus 3, minus 3. Or from the top down, plus 3, plus 3, plus 3. Therefore, since this passes through the origin, and it has a constant first difference, then this is a direct variation. For example 2, we're going to be given two scenarios. And we want to determine the constant of variation for each scenario, then we want to write an equation in the form y equals mx. The distance a car travels varies directly with time, and the car can travel 320 kilometers in 4 hours. So, our constant of variation is m. And we want to state what our dependent and independent variables are. In this case, distance is the dependent variable, and time is our independent variable. So we rearrange our equation and we isolate for m. So we go from y equals mx to m equals y over x. Now we substitute the given sample values, which was this 320 kilometers in 4 hours. We use the sample value to figure out our slope, or our constant of variation. So we do this, and then we found that m equals 80, and so we can write our equation in the form of y equals m times x, which is y equals 80x. Now notice how I leave the variables. Okay, I leave the variables y and x, because y and x will vary. 80 will not. 80 will remain 80 kilometers an hour. So we can input the constant of variation directly into the question, whereas with y and x we leave it as just y and x. The second scenario deals with someone named Sally. And the cost to be a member of the Harry Potter fan club varies directly with time. Now, our protagonist, Sally, spent $85 and has been a member for 5 months. So, cost is our dependent variable, y, and time is our independent variable, x. So, we're given a sample time and cost, and this sample, in 5 months, Sally spent $85. So we can figure out M using our sample. So we have $85 in 5 months. That leaves us a constant of variation of $17 a month. So we're left with y equals 17x. For example 3, the Frederick family is visiting their cousins for the holiday. They travel for 250 kilometers to get to the house. Distance is represented by the variable d in kilometers, and it varies directly with the time t in hours. When t equals 0.5, d equals 43. That is our sample. From there, we're asked to find the slope and write the equation relating d and t. So, just notice in the question, instead of using y, we're going to be using d, okay? And then instead of x, we're going to be using t for time. So d for distance, t for time. So let's move on to part A. So we have our equation of m equals d over t, and m equals 43 over 0.5. Now we know that 43 divided by 0.5 is 86. So using our equation of d equals mt, we find that d equals 86t. Now, what does this constant of variation represent? So, first we start with our m equation, which is 86. And keep in mind that the constant of variation is the slope as a rate of change. So it's the slope value with a unit measurement or unit rate. So in this case, constant of variation actually represents the speed at which the Frederick family was traveling. So in our example, we had t equals 0.5 hours, so 30 minutes, and d was 43 kilometers. So in 30 minutes, we drove 43 kilometers. So if we were to put that in hours, which is what we did here, in 1 single hour, we would travel 86 kilometers an hour. Now we want to use our equation to determine how long it will take the Fredericks to reach their destination. So their destination was 250 kilometers. So we have our equation, d equals 86t. So we have that our d is 250. So we want to figure out how long it took them to drive that distance. So we have 250 equals 86t. We divide both sides by 86, and we are left with a t of 2.9 hours. Therefore, it will take them around 2.9 hours to reach their destination. For our example 4, Amir works part-time at a local bookstore. He earns $7.50 every hour of work. So we want to describe the relationship between his pay in dollars and the time in hours that he works. So let's just state what our dependent and independent variables are. In this case, money is the dependent variable and time is the independent variable. So let's just suppose for a second that Amir only worked for 1 hour. Then he would make $7.50. Suppose he worked for 2 hours. Then he would make $7.50 for every hour. So that's 2 hours. So that's 750 times 2, which is 15. Now suppose he didn't work any hours. So then he would make 750 times 0 equals 0. So for every hour Amir works, he earns 750. His pay varies directly with time, and his constant of variation, or his slope, is 750 an hour. Now we want to illustrate this relationship graphically and represent it with an equation. So we have 1 hour of work giving us $7.50, and 2 hours of work giving us $15. So, in the interest of not having a lot of decimals in our table, I will be using intervals of 2 hours instead of 1, so that our intervals of pay would be 15, 30, 45. It would always be 15, not 7.5. So notice that our time worked, T, is given to us in hours, and our pay, P, is given to us in dollars. So we want to represent this graphically and represent it with an equation. So graphically, here's what it looks like. Notice how it starts at 0, 0 at the origin. And notice how the pay is always a multiple of hours. So at 2 hours, we'd have made $15. Okay? At 4 hours, we'd have made $30. Now to get from 2 to 15, we multiply by 7.5. To get from 4 to 30, we multiply by 7.5. To get from 1 to 7.5, we multiply by 7.5. To get from 10 to 75, we multiply by 7.5. That's what that means for the dependent variable to be a constant multiple of the independent variable. And that's why it needs to pass through the origin. And our equation is then given to us as a constant multiple, as a direct variation, that the pay is 7.5 times every hour. So P equals 7.5 T. In 1 week, Amir works 9 hours. Now we want to find his pay for that week. So his pay for that week is that we're given that he works 9 hours. And we have our equation of P equals 7.5 T. So it is just a matter of us substituting T into this equation, our T value of 9. So P equals 7.5 times 9, which is 67.5. Which, if we were to check our graph, 67.5 would be right here, right in between 75 and 60, right here. This is 67.5 after 9 hours. Therefore, we can state that after 9 hours of work, Amir will earn $67.50. Now we move on to lesson 5.2, where we will be discussing something called a partial variation. Now, a partial variation is defined as a relationship between two variables in which the dependent variable y is the sum of a constant number, b, and a constant multiple of the independent variable. So it'll be the sum of this mx plus b. And so it has the equation of the form y equals mx plus b, where b represents the fixed or initial value of y, also known as the y-intercept, and m represents the constant of variation. Now notice that this does not pass through the origin now. So y is not going to be a constant multiple of x anymore. And we'll see that more in depth. Now, the direct variation and the partial variation are related because the direct variation is just a specific instance of when we have a partial variation where the y-intercept is at the origin. So the direct variation is just a specific instance when b equals 0, and that's how the two are related. Now here's this example where the graph below illustrates the total cost of an Uber fare in kilometers. So suppose we had our cost and our distance. The fixed cost of $2, which is the y-intercept, represents the initial Uber fare. The distance traveled by the Uber, however, determines how much you have to pay for every additional kilometer. The further the destination, the more the Uber will cost. In this case, Uber charges 0.5 cents per kilometer. The equation is written as C equals 0.5D plus 2, where 0.5 represents the variable cost and 2 represents the fixed or initial cost, or the cost when x equals 0. Now notice that the graph is a straight line, but it does not show a direct variation because the line does not pass through the origin over here. This type of relationship, one that is a straight line that does not pass through the origin, this type of relationship is called a partial variation. Another way to describe this partial variation is to say that C varies partially with D. So in example 1, we want to identify which of the following equations is direct or a partial variation and give a brief explanation why. So let's look at example A. We have y equals mx plus b, where m is 4 and b is 0. So we just have y equals 4x. Well, since there is no b value, then this is a direct variation. Moving on to part B. We have a b value of minus 1 over here. So this is a partial variation. Likewise over here, we can rearrange this equation so that it becomes negative 2d plus 10 equals v. So we have a b value of plus 10 and this is a partial variation. Now we want to graph a partial variation. So we want to see this. Complete the table of values given that y varies partially with x. That means that y and x will not be the origin, so the line will not pass through the origin. And we can see that very clearly because it goes through the point 0, 6, not 0, 0. Now, we want to see something. The first differences are plus 3. So we can assume that the missing y values, assuming x is also evenly spaced, which it is, it's going to be 12 plus 3, which is 15, and 15 plus 3, which is 18. Now notice that 18 plus 3 does not equal 26, or 27, I mean. In fact, 18 plus 3 should be 21, and so this is 27. And so we cannot conclude that from 4 to this missing box will be 5 because this is not evenly spaced. So we have no reason to assume that this is also evenly spaced. Therefore, we realize that from 18 to 27 is plus 9. Now, how can we figure out which value of x will give us a value of y of 27? So we find our slope, or our constant of variation, which is found by finding the change in y divided by the change in x. This triangle, by the way, is the Greek symbol or the Greek letter delta. And in math, we use this letter to mean the change in. So when I say delta y, I mean the change in y. So this change in y over the change in x is the same thing as the rise over run. And now we have a rise of 3 and a run of 1. So we have a slope of 3, or a constant of variation of 3. And so, given that we have a constant of variation of 3, we can use this information to find what our x value would be. So, using the same delta y and delta x, we have a delta y here of plus 9. However, we know that the change should always be 3. So we need to figure out how much x changed by in order for us to get a change of 9. So we just isolate for the change in x. So we have our change of x equals 9 over 3, which is 3. And so we can tell now that it's going to be 4 plus 3 over here. 4 plus 3, which is 7. Now we want to identify the initial value of y and the constant of variation from the completed table of values. So we want to write an equation relating y and x in the form of y equals mx plus b. So our initial value of y is b, and the constant of variation is m. We know that. And now remember that the value of b is the y-intercept. So the point on the line where x equals 0. So, looking at this, we see that it is x0, y6. So we see that at x equals 0, y equals 6, so our b value is 6. And we can know from our previous question that m equals 3, which was the constant of variation. So the equation of the line is y equals 3x plus 6. We just plugged 3 instead of m and 6 instead of B. And we can graph this equation and we can see that it does not start at the origin. It starts at 6 over here. And I graphed this on Google Sheets, so it's not like I made this up. For our third example, the school awards banquet. Our school is planning this banquet. However, the cost of renting the banquet facility and hiring serving staff is $675. There's an additional cost of $12 per person for each meal served. So here we can identify the fixed cost and the variable cost of this partial variation. And we know it's a partial variation because it has an initial cost of $675, or a fixed cost, also known as. So we know that our fixed cost is $675, which is our B, and we know that the variable cost is $12 per person, which is our M. And so in order to represent this as an equation, we need to first define our variables, the variables that we are going to be using. So we let C represent the total cost in dollars, and then we let N represent the number of people attending. So since that's our B value and this is our M value, we can just fill in the values of M and B with C equals 12N plus 675. Now we want to use our equation that we found to determine the total cost if 500 people attended the banquet. 500 people is a lot, and that's going to be a lot of mouths to feed. So since we saw that it was an additional $12 for every person that showed up, then we can just insert 500 into our equation to figure out the total cost. So we have 12N plus 675, which was the equation that we found, and that is 12 times 500, which is the 500 people here, plus 675, which is our fixed cost, which is 6,000 plus 675, which is a total cost of $6,675 in order to host this event for 500 people. For example number 4, a gym is offering 2 plans for monthly memberships. So membership A features a cost of $3 per visit. Membership B, however, there is a sign-up fee of $8 or a fixed cost, and then plus $2 for every visit. So we want to graph both of these relations for 0 to 10 visits in 1 month. Now we check and we start with making a table. So we start with our table, membership A and membership B. Notice how membership A has a constant of variation of $3. So it's 3, 3, 3. So it's always going to be 3. So that would be the M value, an M value of 3. However, over here for membership B, it has a fixed cost of $8, and then from there they start adding the $2 fee for every visit. So M equals 2, or $2 per visit. Now we can graph this. And notice, and I did this on Google Sheets, so I just used the values from the table. Now see how it starts at the y-intercept here of 0, 8 for membership B, whereas for membership A it starts at the origin. And there's also something very interesting that you should take note of. It's the fact that at this point right here, so at the point 824, both memberships will cost the same. And this is called the point of intersection, or the POI. You're going to learn more about this in the future lessons. But this point of intersection is very, very important, because as we can see, whichever one is more expensive, so before we reach the point of intersection, membership B costs more than membership A. As we can tell from the graph, it is above, so it has a higher cost per visit. However, after the point of intersection, membership A will actually be more expensive than membership B, because after this point of intersection, they don't have the same slopes, so they're gonna cross each other eventually. And at this point of crossing, the point of intersection, that's when whichever option is most profitable for the buyer will end up switching. So we can classify each relation as a direct variation or a partial variation. So notice how membership A starts at the origin. Okay, since it goes through the origin, then we can tell right away that this is a direct variation. Membership B, however, does not pass through the origin. It passes through the point 0, 8, which is not the origin. Therefore, membership B is a partial variation. Now we want to write an equation which relates the cost and the number of visits for each membership. So again, we define our variables. So let C represent the total cost in dollars, and let N represent the number of visits. So membership A is $3 per visit with no subscription fee or sign-up fee. So it's just C equals 3N. For membership B, however, there is a sign-up fee, which is $8, but then every visit will cost you $2. So our equation for cost to number of visits is C equals 2N plus 8. Now, how would we advise someone who's looking into purchasing this gym membership? Well, we can see from the graph that if someone wanted to go only 8 times, then both memberships would cost the same, which is $24. So if someone was only planning on going 8 times, it wouldn't make a difference which membership they picked, because in the end, once they reached their 8 desired visits, they would have paid the same amount of money. However, if someone wanted to go over 8 times, say they wanted to go 9 or 10 times, then it would actually be better for them to go with membership B, because as you can tell, membership A costs more than membership B here. However, if someone only wanted to go under 8 times, so 7 or 8, or 7 or 6, I mean, then membership A would be the more profitable one, because in this case, membership B is above membership A on the graph, meaning it costs more in total to go under 8 times. So we can conclude and boil all this down to say that the choice of membership depends on how frequently the buyer plans on going to this gym. And more specifically, it depends on whether they're going to go more than or less than 8 times in a month.